All right. We let's just wait a couple of minutes so more people can join us.
Sounds good to
What do you
me.
think? Sounds good
You
to
having
you?
any delay issues at this point, or is it working better than before?
I think it's working well. Can you see me?
Yes, but I'm gonna one up you. That no, keep them on.
No, I'm not sure. Oh, I like it. I like it.
Now everything's blurry and gray.
I bet those are better than mine, which I'm not sure I'm gonna be able to see after I take this off if I keep them on the whole meeting, but the whole recording. Um, but sunny. How's the sun in you're in Montreal now, or where are you?
I'm in Montreal right now. It is lots of snow piled up to my ears, and it's gray.
And
We had like the biggest snowstorm of the last like 3 years, like over the last few days. So cars are,
really?
yeah, cars are just covered in snow, and it's been a lot of fun.
Whoa.
Yeah,
So
you
yeah,
should see
you,
it.
you need your sunglasses.
Yeah, you do. You know, sunglasses were invented by the Inuit up north to
Really?
protect your eyes from the glare. Yeah, yeah, the first sunglasses.
Okay. Maybe we can get started with a little bit of warm up. First of all, we're live in on LinkedIn, Instagram, YouTube, and this is just a fun conversation between two geeks of the AC. We always have these conversations weekly, and we sometimes get really pissed with one with the other. But the idea is to make it public now and discuss some topics. And the idea is that any of you who are there, you can just add any comments and make questions. And the idea is that it's to be an open conversation between us and the community. Maybe you can start with a brief presentation of who you are, Chris.
Yeah. Oh, I always find that it's a bit tough. I'm a 50-year-old computer programming nerd.
Well, you're so much more than that. Never ask your age, but hey, you used to work in Microsoft, Autodesk, and so many impressive startups out there. So you really know you're not just a developer; you're a developer who really knows your stuff.
Yeah, I mean, I've got a lot of different backgrounds. I've been doing like 3D, focused on 3D programming in the last probably like 14, 15 years. But I've been in a lot of different domains, used a lot of different languages. I'm really passionate about programming as a whole, like how to make computers kind of bend to our will and make them do what we want. So I'm really fascinated with the art of programming, programming languages, tools. So and building libraries, all of these things that make programming like easier and make us do more magical things. So that's kind of what I'm fascinated with, and that's what I've been focusing on for the last while.
Okay, I love when you say make computers do what we want. I hope it's not conquering the world, but um,
Well, helping us conquer the world, but nowadays
yeah,
they
yeah,
seem
yeah. I like
full
that. I
scale.
like that. I like that. As long as we're conquering the world, I don't care if machines doing that. Um, and before we get into the weeds of our today's topic, myself also a geek here. I'm an architect, but uh, actually learn how to program, then become an architect, then went into the visualization gaming industry, then director of technology, and now I run my own company where we basically develop cool things for the AC. So yeah, that's me in a nutshell. And today with us, we're going to speak about beam data, which I think it's a controversial topic where our views are different, sometimes common, but many times different. There is something that we've been discussing to start a warm up between, let's start with formats. Hey, I like beam formats in
Yeah.
general. What do you think about that?
Um, I have a lot of thoughts about that. um, I think people say that formats don't matter, and I do think they do because they affect the software and they affect how we use software. So if you have a format, like if you're storing your data in a format that makes data hard to access, you're going to naturally produce less of it. So, you've heard of the Sapir-Whorf uh, hypothesis? No?
No, no.
So like the idea is that language shapes your thinking. So in a way, the formats shape your software, which shape what the way you think about it. So um, so for example, if like I try to do something kind of basic, but it's going to slow down my computer, I'm going to avoid storing certain types of data. And I've seen large projects start off with big ambitions, and then they go, well, geez, that's too much data, and my tools can't handle it. So let's just not produce that data. Let's not even validate it. So formats matter. Uh, I think that's maybe some of the formats we have and then that we're using aren't great, and they weren't necessarily really well designed or really well thought of, or maybe they were designed by committee.
I would- I hope you're not speaking about IFC,
No.
but all right.
Well,
But
I have a love-hate relationship with that format, and of course I am talking about it. I'm not going to be around the bush. I think there's some pros and cons to it. I think it's underutilized. It's got a lot of potential. I don't want to throw it out with the bathwater. Older me would have. Like older me thought that I had some pretty strong negative opinions about IFC. As I've gotten to know it and really understand it, I think it actually has a lot of unmapped potential. And I just have to say, I'm a little scared because what I see with the plans with IFC 5 are some people are proposing just almost throwing it all out and starting again with something completely different. And I'm not sure I'm keen with that. Now, I'm saying that without actually being able to say whether or not that's true. Like when I look at IFC 5, there's not a lot of information about it. There's not much documentation. There's not many examples. Of course, I've looked through what there is, and so it's hard to have like a concrete opinion or an informed opinion about it. Point
no,
is, I think IFC is important. Go on.
no, no. I don't. I'm not sure I agree 100% with what you're saying because to me, formats for sure. You need formats, right? Because you need to exchange data, whether you like it or
Yeah,
not. You need them, right?
you
Like
need to
there is
exchange it and you need to store it. You have to store the data.
correct.
So the formats serve those two purposes. Yeah.
Absolutely, and you always need some sort of format to do it, whether it is something custom of like a JSON file and you're sending a REST API, or something more robust as IFC or GLTF or whatever. But I
Yeah.
do think that in our industry and I know that why, but I do think that in our industry we try to standardize everything, or that's what we want. We're not accomplishing it for sure, but we're all trying to use just a single format and be open and share it between all these different tools. And I'm not sure that's the way. I'm not against any
Mm.
format, to be honest. Like I do think someone says that what a duo we have over here. Thanks, Fran. um I for sure think that, given the fact of the nature that you need to share the data, because I was studying that what other industries have data that is 3D metadata and then it's parametric. There are not that many. Like there are cars and planes, and but the differentiator is that that's just one single company, and they don't care if there is an open format because they can just use their own format with their vendors, suppliers, and whatever. Construction stakeholders changes on every project. So you need a way to have consistency between different projects. So you need to have a way so you can share your data. But I don't think formats are that important. The example is Revit.
Mm.
Like people in the US, they don't use IFC that much, and they use Revit, and everybody uses Revit, and they share data anyway.
Yeah.
Um,
And how's that working out for them?
well, I mean, for me, I think it's working great because that's pushing other companies to build their own startups, and they just create custom connections with Revit. I don't even know one single startup in the whole industry that's using IFC as a means of communication with programs. They use their own schemas.
Yeah. So I want to unpack that. I mean, I think you're bringing up some interesting points. We need flexibility. We need to be able to kind of move data around, but oh man, like having different programs be able to communicate in a standard way is kind of important. Um, and I want to also talk about Revit. When I think that actually the AEC industry as a whole is extremely backwards technologically. I mean, the way they look at data is like people looked at data in the 80s and the 90s, maybe it's part of the 90s, but mostly it's kind of an 80s view on it. It's like, well, nobody's really going to want to access it. So you have one program, Revit, and you have to do everything in it. If you want to work in on a project in another piece of software, that data can't be communicated. So it's like people recreate stuff all the time. So data is duplicated, it's sent over the wire. And this is because we have kind of like this Revit monopoly going on and everything's stuck in the 80s. That's how I feel about it. And I think part of that is like the only way it could be better is if there were standardized ways of moving data. And the best we've got is IFC, and nobody really has good tools for working with it.
Well, that's. I think you bring two valuable points. For me, I think it's easy to just blame Revit when the reality is the anybody can create their own software. The problem is that
Yeah.
it's so hard to do it. I don't think, and
Yeah.
that relates with what you said about IFC, that not many people knows how to, besides the people that just export it and import it to another program, not many people know how to manipulate it from a database standpoint or from a programmatic standpoint because it's so
That's a
hard.
really good point.
It's
Yeah.
complex. So I think it's the problem is related to that, not for Revit, because if there is so much money and so many companies out there that if it were easy, other companies would have just created a better program and cheaper and more modern, and companies would have adopted it. But there is no competitors to Revit nowadays. There are not, because it's really
Yeah.
hard to work to do it.
Yeah. And that's a good point. I mean, I think it's a fascinating opportunity, and I think there's a couple of companies out there. Perhaps that's a talk for another day about some companies who might show up and start to take a bite out of Revit. So, I think we're talking on a couple of interesting subjects there. Um, I find it hard to swallow the thought that formats don't matter.
I didn't
I,
say
I
that.
mean, well, I mean, you're kind of suggesting it, so I'm putting words in your mouth. Okay, so correct me. What's your official view on that?
No, I think they're important, but not as many as people, for example, getting mad for IFC not being, for example, I don't know, IFC, their data is not even binary data, right? Like the 3D data is not binary like GLTF.
Well, not yeah,
So
yeah.
it's not, you cannot compress it. It sucks for translating it and for manipulating in an efficient way on a 3D viewer, and it's the reality. Some people get
Mhm.
mad of IFC. There are always going to be better formats. Like there are
Yeah, yeah.
infinite amount of formats,
Mhm.
and I feel that you just need to use the format that you need. So once you understand that there is not going to be a single format because there are so many different uses and so many different complexities. It's not the same a BIM format for for facility management that is a BIM format for pre-design where you don't need a lot of metadata. So I feel that you always need to
That's a
use
good point.
whatever works for the use you want and not try to use a format for everything. That's what I'm
Yeah, I
saying, that
agree.
you need
Yeah,
to, yeah.
100%. I think the idea of the grand unification, it's kind of a naive thought that we all, when we start off in the industry, we think, yeah, we just need to unify everything, and that's I agree 100%. It's impossible. And like you're saying, like the different jobs that people are doing, the different needs that they have require different formats. And it's kind of interesting because I think we're kind of saying the same thing. Yeah, you do have to use the correct format for the correct purpose. It matters. Um, some of the challenges with IFC are like you say, it's not just that it's not binary, it's just that it wasn't designed in a way that made sense for software to consume it efficiently. So when you design data formats, you want to design them in a way that makes sense so that they can be quickly and easily read for processing, transformation, querying. Um,
Well, that I think you brought a really valuable point,
mm,
because for me, formats are not that important, but I feel it's more important the possibilities to compare it to another format, like manipulation.
yeah,
As long as your format is easy to manipulate, who cares if everybody's using it or not? Because you can
no,
always build your own custom connection to that specific format. If you try to do
yeah,
that with IFC nowadays, it will take you a lot of time. So yeah, the format might be great, but if you cannot use it or manipulate it in a really easy way, nobody's going to use it, or at
yeah, I
least not
agree.
on a programmatic level, I guess.
So the way I look at it, and I'm agreeing with you here, is that it's almost like the ecosystem really matters. And it's a similar thing when you're designing programming languages. It doesn't matter how great theoretically your language is if there are no tools for it and there's no libraries for it. So consumption is incredibly important, and this is why certain formats are quite successful. I mean, there are a lot of tools for generating, loading and writing IFC, just like there are for JSON, for XML. When you look at those generic formats like JSON and XML, it was very easy for vendors to create new, you know, implementations of them, and that's one of the reasons they took off. Same with OBJ. Why is OBJ around? Well, and like, why isn't everyone still now using GLTF and they're still passing OBJs around because it was easy to read and easy to write. So tooling matters a lot, and it really does influence things. What I think people don't realize is, this is kind of like another soapbox I've got, which is they just simply don't understand how coding works and how computers work. So sometimes these formats are not designed by people who actually do coding or have to write the implementations. So a good format is designed by somebody who understands how the computer works.
True, but yeah, true. I agree on that.
Mm,
But then there is, I think it's a double-edged sword, because developers sometimes develop things that are amazingly efficient, but then when people try to understand it, it's like the example between OBJ and GLTF, right?
yeah. Oh, Jill.
Like it's
Yeah.
much more
Yeah.
easier to understand an OBJ structure than a GLTF, and that happens because one is more readable and the other one is not. Um, and one is more efficient than the other. So I think it's a balance, and I think it's great that there are many formats out there. That's my point of view.
That's
Um,
a good attitude. Yeah, I think we need to celebrate diversity. Yeah, and I mean, coming back to the IFC, like what I have to do in my tooling is like, if I want my my application, I'm writing a desktop application. If I want it to be to deal with IFCs efficiently, I have to convert the IFC into something else and cache that. And I think that's a lot how other tools do it as well. Like Libri does that. I've seen other tools do that as well, because you don't want to have to wait 3 minutes to load a big file each time. It's like, well, it should take seconds.
yeah, absolutely. And I also uh, I have a feeling that we tend to compare our industry with other industries. Like it should be like TXT files or PDFs that you can just share. The problem is that the complexities of the data that we have are much greater, and the use of that data is so different between different stakeholders. So for
Yeah.
example, we have worked with many different type of companies that they have dashboards, right? There are
Mm,
so many. I think every other company has Beam dashboards nowadays. Like that, you export
mm,
data to a database. There are even great startups like Beambits, for example, out there. And the thing is, like, everybody does it in a different way.
yeah.
Some has had amazingly big data warehouses. Some others has just exporting used data and not design data. And it varies, and it's great. And if you had to do all that with just one format, it would be impossible. So people, when you actually need to query data, Beam data, not just sending data from one software to the other, but actually analyze your data. Everybody's creating their own schemas. Everybody's creating their own databases, custom databases, and they're just analyzing that data in whatever way they want. But everybody's doing that differently. I don't know if you've seen that or not. With
Yeah, yeah. It seems like, and nobody else can consume their data because you have to kind of know what it means. Like you can't just get the files and go, oh, well, it's self-describing. This is kind of where I wish we could wave a magic wand and have data that told us everything we wanted to know about itself. And that's kind of the dream of IFC, is that we could know that this piece of data, how it relates to everything else, and you can kind of figure it out.
I mean, yes, I feel the good thing about IFC, so I'm not just saying mean things about it, uh, is the relationship between all the elements uh, really makes sense, because you can understand the topology of the building, and if a wall belongs to a room, and if the or a wall is shared by different rooms, and all that information, that it's key when you're defining the ontology of a building, right?
Yeah.
You need that, and I do feel that there are not many formats doing that out there. So if you just need to visualize something, for sure, GLTF is going to be much more better than IFC. And even you can actually add extensions and put metadata there. So if you're
Yeah.
just going to do visualization, for me, IFC doesn't make any sense. It's just stupid. But if you actually need the relationship between the elements, because you're going to modify that building, or you're going to analyze it in a way that you need those relationships, then it makes a lot of sense.
Yeah. It does. It's just, though, it's really antiquated. I mean, there's better ways to do it. I think that if people got together and said, well, let's think about this from first principles. I don't think it's rocket science for some experienced software developers to get together and design an improvement over that accomplishes the same thing. I think, because I think your goals that you described make sense. But it's true that, it's coming back to GLTF. It's interesting. I actually wasn't that knowledgeable about some of the extensions. And I realized that the Cesium team put in extensions into GLTF so that they could move metadata through 3D tile. And 3D tiles is effectively just using, as much as possible, GLTF as is, with extensions. So that's very, very clever. They're using it with instancing and using it with feature descriptions. So, perhaps there's some benefit there if we could provide tools and libraries to make it easier to consume. And that's actually something that I'm looking at doing. But yeah, coming
No,
back to it,
yeah,
is people need to understand it. Go on.
yeah, no, absolutely. And I do feel that when you said that you're building something, I feel that that's another huge gap on the market, because you either have users who are modeling something, creating a building, whatever, on Revit, and then exporting IFCs, and there are other users who are like software developers who are really good at, dissecting that information and creating a dashboard or something. But in between, there is nothing. We have our two technical users, or really basic users. I know computational designers are in between. There are not that many, and we're gonna do a whole episode about if if computational designers should exist or not. But the reality is that there are not that many of those guys, and even those guys, many of them, they don't have they know scripting, but they don't have the capabilities to actually dissect an IFC file, for example. So I think it's a big gap, and that happens because of the nature of the data, which is really complex. Not even firms with big budgets know how to manage. So many of them don't know how to manipulate those kind of big, like, chunks of data. Should we just send everything to a data warehouse as a raw, whatever format I want to use, and then mine it and then create my dashboards? Or what should I do after the project is done?
Yeah, that's a good point. Yeah, I don't know what the solution is there. I mean, one of the things I'm seeing is that people can't share data or they can't analyze data because it's inconsistent from project to project. So this is a challenge for companies that want to gather historical data on their projects, that want to analyze it. I mean, the solution seems to me to simply to have a bit more structure around the data and say, look, we're going to agree that how, some of the key things that we're going to represent around certain pieces of information, rather than just attaching key value pairs to it. So like a lot of people just say, well, okay, this is a wall because it's got a wall family, and then I'm going to put a whole bunch of key value pairs of information, and it's just whatever the designer feels like doing inside of their project. It's willy-nilly. uh,
No, absolutely. Just one thing. Somebody just said agree on the chat, and the like. If someone disagrees or want to pose a question, it's always open. But uh, I think that the ideal world would be if you can just have a standard and put all your models on a database. But the thing is, only the owner can have control, actual control of all of the models. If you're an architect and you're working with different owners, or if you're a subcontractor and you're working with different general contractors, the standards are going to change on each project. So it's really
sure,
hard to maintain, a line on how you manage the data. It
yeah,
depends
I
on
don't know. I
you.
think that's like the standards change, right? But the key things that make up the definition of some stuff doesn't change, right? I mean, what might change is some of like, okay, well, the necessary spacing of, let's say, the width of a hallway in a hospital here, and the distances of doors, and some of these things were going to change. But you could analyze that if people would simply agree upon the key bits of information that need to be stored.
Yeah, I think that's. I don't think that's possible. I mean, that's possible to do it in a consistent way. Even naming the standards, which is like banana, it should be something really obvious. Like we should always name rooms the same way. That's impossible to do from one project to the other. Again, unless you are the owner and you can define like everybody who's going to work on my project is going to do it this way. No way, because you don't have control of it.
Yeah, I see what you're saying. It's a really good point.
Yeah, and that's
Yeah, yeah.
and that's why the, I know it's not being data, and somebody can just say that's not big data. But schedules, for example, is something that everybody wants to uh, mine using AI, so you can automatically create your schedule and whatever. The schedules always have different ways of calling things, and it's so
Well, a
hard
schedule,
to.
yeah, schedule's completely freeform. It's just basically an Excel export. That's all it is, and it's a and that comes
Imagine
back to
translating the complexity of a schedule into a BIM model who has like 1,000 more of pieces.
yeah. But I mean, coming back to it, it's like you still the software and the users know what they're talking about. It's just that that information is lost when you translate it into something schemaless like a spreadsheet or a JSON or a key value table. You're simply going, but I don't even know what it is. I don't care. You don't even know what it is you're talking about anymore because you've just got this random limited 32-bit integer. Well, one of my ideas is simply like you can uniquely identify every single thing that's ever been designed or created can be uniquely identified, and it can be consistent. Now, the software doesn't do that, and that's a limitation of, let's say, for example, just the way Revit's designed. It's and the way, again, it's stored in IFC. IFC is like, well, you can use a whatever the 32-bit integer for your ID, and then that's specific only to one instance of one file. And it's my point is you can add some more structure to the data. You can be a bit more rigorous without trying to solve all of the problems. And there's a lot of benefit from it. I mean, look at it this way. Structured databases, relational databases exist for a reason. They force a user to say, look, I'm going to have a structure, and now I can make generic queries across it, regardless of the database system I'm using, because they all standardize, they all speak SQL, rather than just saying, it's in a random text file. Like text file for me, even spreadsheets for me, is the equivalent of somebody writing stuff down on a piece of paper in their own handwriting and just sticking it in a pile. And that's the way I
You're
see
saying
construction data.
you're saying
Go on.
too many mean things for a Canadian. No, I'm just kidding.
We're secretly mean. We're not
Yeah,
mean, but we can
yeah.
be harsh. Canadians are actually, when people meet Canadians, they're going, "Wow, you're polite, but then you speak these harsh things." I'm like, "Yeah, well, we're opinionated."
Well,
So
that's I
yeah,
think it's something very valuable what you were saying, which I think our industry lacks. For example, like, and a good example is Postgres, right? In Postgres, you can add extensions, right? And there's a really good extension called PostGIS, for example, right? Which is,
yeah,
it can be similar to what we do in our industry. And PostGIS works for, instead of like beam data, is for geographic data, right? And it's a great extension because as soon as you add, for example, a lot, it automatically can calculate if the lot belongs to a municipality, and if the municipality belongs to a city, and if the city belongs to a county, and if the county belongs to a whatever. So relationships are automatic, and there are great extensions for that. So that's not a format, but it's actually an extension that you can use to create your own schema on a really smart way for geographical data. I do feel that, or I have not seen yet, maybe there is something out there that can be something that helps users not on a format level, but on a database level to create extensions and to adapt that to their own schemas, but with a logic that makes sense for Beam.
yeah, yeah, yeah. I think it makes sense. And I mean, we have to realize too, what your earlier point, that it has to vary depending on the use case. Like all data is not equivalent. A structural beam has a different set of data depending on what the project it is, who's looking at it. I'm talks with Greg Schlossner from HOK, and he's kind of like pointing out that data, you have to have different versions, variations of data for different use cases and for different purposes and different moments during the project. They're all relevant. They all have to be linked together. Yeah, I think there's some potential for that, and I think he also proposes that um, an approach which uses like schemas to define the bits of data that we care about. You don't have to have a schema for everything, and it's not the same schema for everybody.
Yeah,
But schemas allow you to have meta information, which tell you, well, this is the structure of the data, and now programmers can build more interesting tools. And data has more
yeah,
value
absolutely.
because you have more meaning associated with the data. It's not just, well, there's a number and there's a label, and it's what is it? We don't know. We've lost the context. Because that disappeared ages ago.
Yeah, absolutely, absolutely. I do also think that once we have better tools to query the data, I think the bar is going to be, because nowadays whoever wants to modify the data or do something, you have to be a really advanced user, right? You need to know
Mhm.
coding, you need to know databases, you need to know about data, you need to know a lot of things that is so hard to do.
Mm. That's a
The
great point.
problem is,
Yeah. Yeah.
yeah,
Go on.
once we have better tools that are online that like even allows people to see the whole thing, and even get, like you said, give different permissions or give different granularity of the data for different users. Nowadays with Revit, you cannot even have that. You have to separate it on a completely model to make sure that they are modifying that and not touching your model, and it's just insane. Sorry, Revit, I love
Yeah.
it,
Oh, that's a
but
great point. I think, yeah. No, I think you're right. I think better tools are better information. Maybe the formats will update a little bit afterwards. But yeah, I think I've always been kind of thinking about this for a long time. Well, the chicken and egg problem. I'm like, well, if we just put everything in a good format, everything would go away. But as you're pointing out, it's like, well, the tools have to exist first. So my current thinking is if we can build better tools to extract data out of IFC files, because there's a lot of data in IFC files, there's a lot of interesting information. It's just hard to do. And the existing open source tools are quite limited. And I think, I'm proposing an effort to try and improve that. I've done some work on libraries built around that, so that we don't have to, so we can get more information out of it more easily. So, and then making it accessible for everybody. And then afterwards, maybe we can figure out ways to store it more efficiently.
True. I think it's getting easier and easier also to create tools, because one of the, I think, biggest problems is renderizing all this data, right? Like dealing with 3D geometry, it's kind of a hard thing. But I think the bar is being, it's lower and lower every year. It's like today I was looking at a graph of 3JS, which is the most common 3D library in the world. Um, and the downloads, I think it went 10x from 2022 or 2023 to 2025, because that's the other thing. We're in a 3D world, and most of the other industries are still on a 2D world, but the website is changing. I do feel that there are going to be more and more websites that are going to be 3D. There are going to be more and more complex graphics. There are more, like, even industries like movies are trying to create movies where you can rotate the camera. So I'm not going to be able be watching the same movie you are going to be watching, because I'm going to be able to rotate my camera and go around. And for that, you need much more complex technology. And I think that's lowering the bar for many more people to easily create kernels and create viewers online. And that will lead to much more tools that are going to be potential Revit competitors. Yeah, I think that's the case. But I think it's going to be, I don't know, I don't want to get off the rails, but I think it's going to be completely different of what Revit is today. Um, I think that we're going to be seeing on the market smaller tools that are going to be niche tools for just one specific use, not something that is just for MEP, architectural, structural, the whole thing. It's just going to be really niche tools. And that's when I feel formats are going to lose its validity, because just tools are going to
Yep.
communicate with each
Yep.
other
That's a
directly
really
with
good point.
APIs.
Yeah, what we want. Yeah.
Yeah, I don't know. I think that's going to be the paradigm that is going to change, and I do feel that there is a great opportunity for everybody to jump on that train and take advantage of that, because everybody thinks that everything
Well,
is
that's
already
interesting.
invented.
Play through APIs.
Yeah. More. I think you have a little bit of delay on your audio. I don't know why.
I definitely agree that there's going to be, I mean, the age of the monolith
I think
delay.
it's just a couple of seconds.
Hold on a
But
second. How about now?
yeah, sure. I think it's better. We don't get to see your pretty face, though. But
Let me try again. Let's try again. How's this?
I think there's more like, maybe if you remove the background, or I think you tried that
Oh, yeah,
previously
let's
and
try
it
that again.
worked.
All right. We're going to remove that. All right, here we go.
Okay. Yeah, I mean, formats are gonna still exist forever and ever. I don't think that's ever gonna stop, and maybe until AI is so smart that it can connect automatically between APIs, which I also think is gonna happen eventually, but
Well, yeah, that's kind of
not
what
in
you're
the near
suggesting.
future.
Yeah, I was thinking about that when you're talking about uh, applications talking to each other just through the APIs. I mean, obviously that'll be enabled through AI, but I mean, at the same time, the APIs have to be smarter. So it's almost like the same conversation we're having about how formats have to be more structured. The APIs themselves are going to have to contain more information about the data that is being transported back and forth. So maybe we're going to have like meta layers of APIs that describe the data that you want, and then the transport is in whatever, whether it's JSON, XML, binary, file buffers, whatever it is, we don't care. But then you'll have APIs that actually can describe the data in a meaningful way.
True. It's just that's an interesting topic, because another thing is, and I think a lot of companies, you zoom in. I do feel a lot of companies are trying to accomplish this, and is how to take um, how to squeeze the juice out of the beam data with AI, right? How to process beam data using AI.
Yeah, yeah. It's almost trying to figure out the structure without it being explicit. It's like, can AI actually figure out a structure? Yeah, it feels like it's a funny way to do things. It's like, well, they could have just been put the data in a better structure to begin with. Yeah, I mean, it's an open problem. I mean, can what can AI do to solve this problem? You still need to
Uh,
store it somewhere, and you still need to be able to query it. You know, and you're going to need a database, and so you're going to need some kind of schema, I think.
no, absolutely. But the thing is, the data needs to make sense because, like, if you cannot understand it, AI is not going to be able to understand it either. Like, it's not that it's going to do magic, right? So
Mhm.
I don't know. That's my guess. Uh,
Well, the AI can do magic. That's the interesting thing about AI. AI can find structure that's implied that is very hard for a human to extract. It just can't do it like completely reliably. But
I mean, it can do it faster than the human can nowadays.
yeah, yeah,
It's
it
not
does.
that,
Yeah, that's true.
yeah, it's not that it's not, it's doing the same human is doing, but faster is not better.
Well, I mean, it can
Um,
also automate things like that. People we just can't afford. Like, I mean, it feels like in industry, everybody's at 100% capacity. Nobody has any room to do anything more than what they're currently doing. So this is where AI can be useful, is because it allow you to get those extra hours that you don't have. It feels like everybody's profit margin is this, that thin.
True.
So
No, no, absolutely. And I also feel that we're a little bit unfair about just saying AI because it's not the same an LLM and then just throwing random beam data into an LLM than machine learning, right? That
yeah, yeah,
if
that's
for
what we're
example,
talking about.
exactly, if I'm gonna automate, let's say a modeling process of MEP or whatever, right? I want to automate it because, and that I think that's gonna happen, and there are startups working on this. Um, I want to automate how whatever it's HVAC. I want to automate how HVAC is being modeled or piping. For that, LLM is not. You're not going to use LLM. You're going to use machine learning. And
Mhm,
if you
mhm.
want to use machine learning for that, you need to train it on consistent data. And to get
Yes,
consistent data, you need to what? Have it
structure the data.
standardized.
Yeah.
Otherwise, you're not going to be able to train that.
Mhm.
But by the way, there is a question of someone here.
Yeah. What?
Uh, what should computational designer learn to upskill them in this format and file transfer and data workflows with Beam? Push. Um,
I mean, I'll take a stab at it. It's a question of learning as many tools as you can. Moving data between places, there's so many different options and there's so many different paths. And so you have to almost do a fair amount of experimentation to figure out the way to move data from one place to another. So you need to familiarize yourself with tools like IFC Shell. Learning a little bit of Python scripting can get you a long ways. Listen to whatever Dion Molt tells you, because that man can do magical things in one line that you don't think is possible. So, you know, it's crazy. What else can you other skills? Like for me, it's about knowing what the tools are that are out there. A lot of any type of computation is simply about taking two tools and wire them together. You don't have to be a coder to do that. You simply have to try different things and inform yourselves as to what's out there. What do you think?
no, absolutely. I agree that you don't need to be a software developer, and I hate when people say you need to be a software developer. No, not really. Like you can be an architect and just be really good at with analyzing data. I feel that the first thing you need to understand is what are you going to use the data for? I
Yeah, oh
mean,
yeah, 100%.
that's the
Yeah,
most important question. Then, if you know exactly what you're going to get out of it, then it's easy. You can just dissect the data for sure. You can do a little bit of courses on scripting, on how to process data. It will be great if you learn about that databases and what's the difference between uh, SQL and non-SQL database, because both of them are useful, but the way data behaves on one or the other is different. It'd be great to learn about formats, and I don't know what's the difference about a binary format or an explicit format or compressed, something that can be compressed or not. Also, schemas. For me, I'm really bad on data, on the data side, but I think schemas are the best thing to learn, like how to put together a schema. And it's about logic. It's not that much about learning a specific programming language, but logic that serves your purpose. Like if you're doing pre-design, for example, you only care about square footage, rooms, uh, views, and construction code. That's it. So you just need a schema that helps you to do that. You don't need like really complex stuff. So it depends on the use. So yeah,
Yeah.
my answer was really long, I feel.
No, but I agree. You have to know the use case and you have to look at the tools. And I find that the more a person knows sometimes, the more likely they are to make a complicated choice. Sometimes. And it's like, never be satisfied. Always look for a simpler way to do things and really do your research first, because any problem you've had, somebody else has solved it already. So don't reinvent the wheel, and really look hard for what exists out there, and make sure you inform yourself as to whether or not it can solve your problem, because it's all about solving the problems in an efficient way. So
Yeah,
yeah,
and also open engineering, and this I think
yeah,
applies to data, to startups, to everything. I think in general, people in our industry tend to and I used to do that as well. It's
yeah.
tempting and it's fun because if you're a
Oh yeah,
geek, but over engineering is a nightmare. You can just do anything with just a little bit of work, and that's it. You don't need
for
to,
sure.
like, for example, if you're going to start centralizing your data, don't think of, I'm going to take 1,000 models and I'm going to put all of them together on my, just start with some piece of data that is critical, just that, and then you can make your way to make it more complicated over time, but don't start making it complicated and trying to simplify it over time, because that would be a nightmare.
For sure. And the other thing to avoid is under engineering. Don't try to build something, that you want it to scale, and then just start with toy examples and toy technology and it doesn't scale. You can do an experiment to prove it to yourself. But sometimes I feel like people they've got a big ambition and they're just working with toy examples, or they don't have enough knowledge. And then they kind of get themselves in really deep trouble. I mean, if you're building a tool, so if you are building a serious tool for your organization or for the industry, you have to make sure you do test it at scale and that you are taking into account the fact that it has to handle the loads. So my recommendation is to engineer to the appropriate level of requirements. Okay. So don't over engineer if you need something simple. Don't under engineer if you need something big and complicated, because like there is a time and a place for it, right? Like,
Yeah, no, absolutely. I disagree a little bit in there, because I always think that it depends on the stage you are. Like,
yeah,
for
yeah,
me, if I'm developing an internal tool for my company, I would just do the most crappy code I can, and but it doesn't mean that I'm going to deploy it for the whole company. It just means that I'm going to show it to the right people, and I want to make sure that I'm going to get traction in the next stage. For sure, if I have to deploy it to the whole company,
yeah,
or I have to sell it, for sure, I need to have the right balance and not over engineering, but not under engineering. But at the
yeah,
beginning, the first thing you do needs to be super fast, super ugly, super cheap.
yeah, within reason. I mean,
That makes sense.
I'm just gonna counter. There are times when that's appropriate, right? But there's times when you're building something substantial. And I've had enough people come to me and say, "Hey, look at me! I'm going to build a skyscraper." I'm like, "Yeah, but all you've ever built is a tree fort in your back house. You're not going to get to a skyscraper." And then they're like, "Oh, I'm building a skyscraper," and I'm like, "Fine, whatever." It's just It's be aware of what your limits are and where you're going, and don't overestimate just simply because I have so many people build small pieces of small toys, and then they're like so proud of it, and but it's not going to scale. And that's kind of one of my issues in the industry, where I have people just building toys and then saying this is the future of the industry. I'm like, no, it's not. And that's, that may be by part of our topic, where startups
Yeah,
go
yeah, yeah.
wrong.
But
But
yeah, yeah.
I'm
Well,
just, yeah.
there is something saying that maybe all of us will buy out all startups, but
Well, that definitely is their
I,
strategy, isn't it?
I mean, they're buying a lot of startups, but there is a limit to that.
Yeah, there
And
is. Yeah.
like Procore is a good example. They tried to buy Procore and they couldn't, and now Procore, they're sharing a big piece of the market with Procore, and 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 I do feel that now, like when they, for example, they bought Spacemaker, it was just
Hmm.
Spacemaker and two other companies out there. Now there are like 20 or 30 companies trying to do it. So I think nowadays the technology and the bar is being lower and lower to create this type of complex tools. So I do think that they're not going to be able to buy all the companies they want because there is a limit to
No.
that. And now it's getting cheaper and cheaper to actually do this. And also the fact of niche, like Hayek, for me it's a good example out there. Like they're building a startup specifically that you can design your own house without the need of an architect, and then they connect you to someone who's going to build it.
Hmm.
And it's just a niche, so there are going to be so many companies that Autodesk is not going to be able to buy them all. That's what I hope, at
Yeah.
least.
Yeah. I mean, it's interesting. I mean, a lot of larger companies, as they grow, they become more risk averse. And rather than trying to invest internally, they just wait and see which startups are the most successful, and then they purchase them. I mean, it's a good model. It makes a lot of sense. Um, and like you say, it's there is going to be a change, and I'm noticing it myself. Like with the aid of like ChatGPT, like I got a pro version. Oh my gosh, I my productivity has really grown, which is incredible. So all of a sudden now, as a smaller company, I'm able to accomplish more. And as you're saying, like the kind of the bar is lowering all across the board. We're seeing it with 3D. We're seeing it all across everywhere. So as more technology is invented, as AI gets better, we can build startups cheaper and cheaper, and we can accomplish more. And then hopefully there'll be enough of an ecosystem out there that maybe they'll be more competitive. I mean, that's my hope anyway.
No, no, absolutely. And I also think the same applies to data. That the way we the difficulties we have nowadays because of the scale of the beam data and the complexity of 3D, and that's also getting easier and easier.
Yeah, it is. Yeah, yeah.
It's getting easier and easier. Like if like you try to do an online modeling tool, live modeling tool 20 years ago, that would be impossible with all the infrastructure, the internet speed, and so many other things.
That's good.
Nowadays, you can just do it. Like there are so many doing it, like Snaptooth or any other many other startups. So it's also lowering the bar for people to easily manage data, chunks of big data, and send it to a data warehouse and process it with Power BI. Power BI, amazing tool that you can just visualize huge pieces of data, and there are so many people doing it, visualizing Revit data there, even IFC. There's a connector of IFC and Power BI,
Mhm.
and you can do that because of technology. So I also think the way we manage data, the formats, the interoperability, it's also going to improve a lot in the short term.
Yeah, yeah. And that's the hope. But I mean, that's what we're working towards, eh, is to make data more accessible. I know your company's doing that. My company's doing that. Uh, yeah, it's true.
Yeah.
There's kind of like a democratization happening of data.
All right. Yeah. No, absolutely. A bright future. And with
Yeah, yeah.
this, what do you think if we wrap this up? We don't want to bore all these poor souls that are listening to us.
Yeah, I'm looking forward to our next discussion though. It's that's going to be a fiery one because we're really disagreeing about it.
Yeah, yeah, it's about if you need to should learn how to code or not. So guys, if you're listening, tune in 2 weeks. We're going to be discussing if you need to
Well,
learn how to
technically
code in
3 weeks.
VC. Oh, 3 weeks.
3 weeks.
Sorry,
So yeah,
three
March
weeks.
13th.
March 13th. Sorry, 3 weeks, and we're gonna be also discussing if computational designers should exist or not.
We're gonna snap our fingers like Thanos, and the computational designers will suddenly vaporize.
Get the feeling a lot of people are gonna hate me a little bit there, but we're gonna
It's
try to be
impossible.
nice. Yeah,
It's impossible to hate you. We can disagree with you. It's impossible to hate you.
it is. All right. Thanks everybody for listening to us. Hope you had as much fun as we had, and hope to see you in the next recording. All right.
Wonderful. Thanks a lot,
Okay.
Valentin. Fun as
Thanks,
always.
Chris. Yeah, fun as
Take
always.
care,
Bye
everyone.
bye.
Bye.